Hello, everyone. Welcome to the new normal. Hope everyone's doing well and everyone is being safe and smart. Um, for now, this is how we'll be doing most of the PowerPoints. I'll be narrating these various slides. You probably should listen. Maybe different from normal in class, but should be close to the same. So, our next unit will be Earth's history, looking back how the Earth was formed, as well as how we know things were formed. So as we go through, look at the slides, there'll be a copy of the notes attached to it, and listen to what I'm saying. I'll narrate the pictures, have links to videos, so just follow along what I ask you to do, and it should be fairly easy. So go to the next slide. So we first have to look at how old the Earth is, and how we determine how old the Earth is. So Earth formed about 4.6 billion years ago. This is done through various tests. And the Earth was formed when rock, dust, and gases were drawn together by gravity. As we know, gravity brings everything together, so it's how we got our inner core, outer core, our mantle, and our crust. We look at all the rocks in our crust, and from these we see we have clues to Earth's history. So like a puzzle, we put them all together. So geologists need to locate, observe, interpret all these evidence and clues. And once we have those clues, they give us a sequence to the geologic events that created this Earth. And once we have a few things in the sequence, we can create our timeline of when things happen from the Earth began to our current events. So to look at Earth's history, we have to understand some principles that are common throughout all of history. The first is called uniformitarianism. And that'll be the only time I'll ever say that because I can hardly pronounce it. This is telling us that what's occurred today has occurred in the past. That the processes are uniform. That if something happened 20 million years ago, it happened again in current time. And then the other principle is called superposition. That means the rocks at the bottom of a sequence of rocks are usually the oldest. The older the rock, they have to be in place before new rocks are deposited. It's like making a sandwich. You cannot put any meat or lettuce or whatever else you put in a sandwich before you have the bread down. So the bread would be the oldest rocks, and however you create anything is always the younger stuff on top. Another principle is called original horizontality. That just means that all sediments are deposited in flat layers. As we look with landscapes and other rock features, they're always laid down flat and then through plate tectonics are curved. And when they're deposited in both lakes or oceans, in water. So most of the rocks in New York State were put down as flat layers. The plains, the lowlands, and the plateaus. This means that New York State was generally underwater for most of its history when the rocks were formed. Then we have correlation. We break it up, it's called correlation. It's a critical tool that we use because we look for a sequence of rocks, or the order of them, in 2 or more areas. It could be 2, 3, 4, up to 10, whatever. And when we look at them, if we see the same sequence of rocks in 2 different areas of this, we can say, okay, they're now the same age. So we can look at rocks in New York State, in Pennsylvania, in Ohio, and if they have similar sequence, we can infer that they were created together. There are 2 ways to look at geologic time. We have what's called relative time, which if we know the order and sequence of the rocks, but we don't know their actual dates, we can say, okay, well, this one is relatively newer or older than the previous one. And that's what we're looking at today. The other type of time is called absolute time. This is an actual number. So it's the actual date of when the rock layers were formed. If I know two dates, then you can find the rate of change. So we can see things like mountain building, or deposition, or erosion by looking at what's there before. The formula for rate of change is on the front page of your reference table, and the box with the other three formulas that you need to know for this class. So first we're going to look at finding relative time. Once again, superposition, the rock sequence will be the oldest on the bottom, if the sequence is undisturbed. So things like folding and faulting can put another older rock on top of newer rock, though it's usually very rare. If you have cross-cutting, when igneous rock is intruded into the rock, the igneous intrusions, so from a volcano, a hotspot, or just a weakness in the ground, well, that has to be younger than the rest. Intrusion means to cut across. You cannot cut through a larger rock bed, or in case of a fault, you cannot have a fault go through rocks that were not there already. So these always happen after the rock layers that they have broken up or come through. Then we have included fragments. If we have a rock, such as a conglomerate or breccia, that are made of fragments of other rocks, well, those fragments had to be older than the newest rock, because those fragments came from a previous rock that was broken down through weathering and erosion, and then cemented together to become a new rock. So the pebbles of conglomerate are always older than the conglomerate itself. But the cement that makes them into the conglomerate would be the middle stage. In this picture, this red layer on the bottom would be older than the green layer, which is older than this yellowish brown one, then the gray, then the brown on top. So, as the arrow points out, whatever on the bottom is the oldest, the ones on top are the newest. For igneous intrusion, the magma squeezes into or between layers of pre-existing rock. This is the igneous rock that usually goes in between a sedimentary rock, or layers of sedimentary rocks. In this case, we have our intrusion right here, this red line. This is our igneous intrusion. In blue, we have our sedimentary flat layers. So the igneous rock can only come through once those flat layers were already put down. One of the most important things to know about igneous intrusions is this green layer, the outer boundary of the igneous intrusion, because of the heat from the intrusion, creates a metamorphic rock. This is contact metamorphism. That's the bottom page of your metamorphic rocks. And because hornfels is created from any contact of any rock, this is either whatever the sedimentary rock being metamorphosed, or a common answer of it's always a hornfels rock. On this picture, you see here that I'm going with red. This intrusion cuts through every single layer in the picture. Therefore, it is the newest of everything because it cuts through them all. Over here on the right, well, this cuts through these layers. This intrusion is newer than the previous layers below. Since it doesn't reach the top, it is not as new, therefore it's older, as the layers on top. The fault on the left, that I'm trying to highlight in yellow, since that is cut between all these layers that should have been flat when they're deposited, that fault is newer than those rock layers, but since the fault doesn't extend above this layer over here, then green, since it's not cutting through that, the fault is not as new as this and the layers above it. On the right, you have this intrusion over here. Now notice, this cuts through these layers, therefore it's newer than those layers. It also cuts over the fault, because it's not displaced by the fault. So it is newer than this fault. However, since this igneous intrusion cuts through this other intrusion, it is older than this secondary igneous intrusion. But since this intrusion over here cuts through all the layers, and since we compare the left side to the right side, since these are continuous layers in the middle, this is the newest feature of the entire picture. This is a conglomerate rock, so those fragments are all older than the actual rock itself. Those fragments could have been from other conglomerates that are broken down, or metamorphic igneous rocks broken down by weathering and erosion. So the fragments are the oldest part, the conglomerate itself is the newest part, and there's a third part, the cement, that binds them together. Usually it's clay and silt, smaller sediment, is usually the middle part. So it would go in order from oldest to youngest, fragments, cement, conglomerate.